You should recognise almost immediately as being integration by parts. The clues are it's something times something else, and there's no real relationship between those two things. So integration by parts. Now when you integrate by parts, there's one decision to make, and that is which one of these you're going to integrate and which one you're going to differentiate. Always differentiate the thing that's going to be made simpler. X becomes simpler when you differentiate it, so differentiate x. So I'm going to let u equal x, in other words u primed equals 1, v primed equals cosine x over 2. So v, needing to integrate that, must have come from sine x over 2, and now I'll just check. When I differentiate sine x over 2, I'm going to get cosine x over 2, but I need to multiply by a half, so I need 2 of them to make it so that when I differentiate, and the half cancels with the 2, or whatever. So now I just need to put that in to the formula. So the integral I'll call I equals 2x sine x over 2 minus the integral of 2 sine x over 2 dx. And the integral of sine x over 2 must have come from cosine, so I'll just write this out as I'm going. 2 sine x over 2. Integrating sine, we get something to do with cosine, so it's going to be something to do with cosine x over 2. When I differentiate cosine x over 2, I'll get minus sine x over 2 multiplied by a half. I want minus 2 of them, so I need 4 of those. And it is positive because the cosine itself differentiates to make minus sine, so that's all taken care of there. The 4, once again, it's 4 because this half is going to come out by chain rule when we differentiate to cancel with the 4 to make the 2 there. And I should remember to write plus a constant there, so that's 3 marks. Part B, express something in partial fractions. Part 2, sorry, question 2. Partial fractions, then we get 1 over x squared 1 minus 3x must be identical to something over x squared plus something over x plus something over 1 minus 3x. Doesn't matter what you call your A, B and C, you might have got them in completely different order, doesn't really matter. Now, then multiplying everything by x squared times 1 minus 3x, we get 1 equals a times 1 minus 3x plus bx times 1 minus 3x plus cx squared. And now we can choose whatever values we like. This is an identity still, so we can put whatever values we like in for x at this point to try and find what a, b and c are. The most straightforward thing is to put x equal to 0. Put x equal to 0, we get 1 equals, if x is 0, we get a here. If x is 0, the reason for choosing x is 0 is that makes the b bit disappear and the c bit disappear, so a equals 1. Now, that's if x is 0. If x is 1/3, chosen 1/3 to make this bracket 0. If x is 1/3, we get 1 equals nothing to do with a, nothing to do with b, 1/9 of c, so c equals 9. And now we can choose x to be anything we like. I'll choose x equal to 1, just to show you it doesn't really matter. If x equal to 1, then we get 1 equals, okay, x equals a minus 1 is what I'll choose to avoid negatives here. If x is minus 1, we get, this will become 4a. We know a is 1, so that's 4. If x is minus 1, still, then we get 4 times minus 1b, so minus 4b. And if x is minus 1, we get plus c, and we know c is 9. So we get something like that. So I think that leaves Oh crikey, that doesn't look too healthy. That leaves b equals 4 and 9 is 13 over to that side is 12. B equals minus 3, I think. Is that right? Or b equals 3. No, b equals 3. B equals 3. Got it right now. If I wrote it down a bit better, I'd see. This equation is really easy, but b equals 3 is what we end up with. So the answer to the partial fractions is, and we're actually going to use that in the next part as well, the answer to the partial fractions is that it is 1 over x squared plus 3 over x plus 9 over 1 minus 3x. And now in the next part we're asked to integrate this thing. If we remind ourselves, we're not asked to actually integrate that, we're asked to integrate something which looks very different, but we've just done the hard work in this part here. So integration now should be fairly straightforward, we'd hope. And we should be able to just write down the answer. So integrating 1 over x squared, just as a reminder, we'd write that as x to the power minus 2 in C1 and integrate that to make minus x to the power minus 1. That's what that's meant to say. So that becomes minus 1 over x. 3 over x, this is where we learn about logarithms. It's 3 times the logarithm of x. And when you differentiate 1 minus 3x, you get minus 3, so it's minus 3 times 1 minus 3x. Logarithm of 1 minus 3x. Plus some sort of constant there. But in actual fact, the mark scheme's pretty lenient with all this. You could almost not even simplify the coefficients as long as they're correct.